Okay, 8th graders, if you are watching this video, you just completed part 2 of this assignment and you are looking to make corrections on the 2.3 force and motion modeling tool. So I'm going to kind of walk you through some activities that are going to help you guys kind of conceptualize what's going on with the pod. So remember, we had 2 claims with the pod. The first was that the pod just turned around and moved in the opposite direction. Okay, in chapter 1 we thought maybe that was because there was too much thruster force, but we found out that wasn't the case. Okay, claim 2 was that the pod only slowed down, it didn't stop, and that eventually it hit the space station and bounced off and moved in the other direction. Okay, but again, we found out that it wasn't due to the thruster. So in chapter 2, we were taking a look at the mass of the pod. What if the pod collected too many asteroid samples and had a larger mass? And what if the pod could have maybe collected not enough asteroid samples and had too light of a mass compared to normal? So you guys are going to kind of test this out in the sim. This should look fairly familiar to you guys. You've done an activity very similar to this before. Okay, we're going to use 3 different pucks to represent the smaller mass of the ACM pod, the normal medium-sized mass of the ACM pod, and then the larger mass if we had too many asteroid samples in the pod. Okay, so you guys will open up that sim link and you guys will use the 3 different pucks. So again, a 0.5 to represent our A. Oops, I'm going to delete that. Sorry. All right, a 0.5 to represent our lighter puck. Our normal puck is going to be our puck B, and then a 2 kilogram puck is going to be our heavier than normal asteroid collection pod. Okay, so all of these pods are moving at a medium speed, so set all 3 pucks to move at 2 centimeters per second to the right. So you guys should have said, all right, puck A, 2 centimeters per second to the right, puck B, 2 centimeters per second to the right, puck C, 2 centimeters per second to the right. Okay, so then on that, I'm going to go ahead and apply a force. Because nothing was wrong with the thrusters, the pod always fired with a medium force to the left. So we're going to do just that. We're going to apply a force. Here we go, hit run, prepare force, and we're going to do a medium force out of 1, 2, and 3. A medium would be 2 to the left, because remember the thrusters work to slow the pod. Okay, and then if I hit exert, I can see, all right, puck B, which is our normal sized pod with the normal thruster force, that puck stops moving like it's supposed to. Okay, puck A, which was too light, okay, started moving to the left. Okay, puck B just slowed down just a little bit. So it was going, let's see if we look at the exact analysis of this. You got it was moving 2, and then puck A turned around and was moving 2 in the opposite direction. So that was a change of 4. Object B, or puck B, was at 2, and then it stopped moving again. Remember, this represents our normal pod, our normal mission, or our normal pod. And then object C was moving 2, and then was moving 1, so it just slowed down by 1 centimeter per second. Okay, so if we look at this, you guys have a couple questions to answer on this. Object A had the smaller than normal mass. What change in motion did you observe when it was hit with a force of 2 clicks? On this one, you guys should have put change direction. Okay, which claim is this dealing with? Okay, so we just kind of represented this in the sim. Okay, of our 2 claims that we talked about with our pods. Okay, which one does this represent? Remember, claim 1, it turns around and moves in the opposite direction, whereas in claim 2, the pod just slows down, it doesn't stop. Okay, so on this one, for puck A, the smaller than normal, it changed direction. Okay, on this one, claim 2 stated that the object just slows down, so this one slowed down, which was puck C, and so this one would kind of represent what would happen if we had more asteroids than normal. Okay, why was this change in motion different for all 3 pucks? You guys should probably talk about mass and say the more mass it has, the more inertia it has, therefore it takes more force to move it, or even something as simple as saying, yeah, the heavier it is, or the more mass it has, the more force is needed to make it move. Okay, so you guys should have answered something along that line. And then finally, claim 1, normally the medium mass pod stops if a medium strength thruster force is used. However, if the pod was carrying less asteroid samples than usual, its mass would be smaller. Assuming the thruster exerted the usual medium force in the opposite direction, how would the pod's motion after the force differ from the normal medium mass pod? So you guys should answer that saying that the lighter mass pod should turn around and move in the opposite direction. Remember, in the sim, puck A represented a lighter mass pod and puck B represented the normal pod. So again, that lighter mass pod that had less asteroids than normal would turn around and move in the opposite direction if we use the normal medium force. Okay, then you guys need to answer this one. So claim 2, normally the medium mass pod stops if a medium strength thruster force is used. However, if the pod was carrying more asteroid samples than usual, its mass would be larger. Assuming the thruster exerted the usual medium force in the opposite direction, how would the pod's motion after the force differ from the normal medium mass pod? Remember, in the sim, puck C represented a heavier mass pod and puck B represented the normal pod. So you would say, all right, puck C just slowed down. It was moving 2, and then after we exerted the force on it, it was only moving 1. So it just slowed down. It didn't stop like the normal pod should. And then if we look at puck A, which was less mass, it didn't turn around and move in the opposite direction. Okay, so you would say that this one just slowed down instead of stopping. So that's how you guys would explain the difference there. And then on the next slide, you're going to say, all right, take a look back at your 2.3 force of motion modeling tool. What was incorrect? So take a look back. Tell me what was incorrect. Again, you guys might have to tell me that in person. I'm not going to know how you're going to respond because I don't know what you missed on that. Okay, and then same thing here at your 2.3, claim 1 on slide 4 versus claim 2 on slide 6. Those two got flip-flopped. Okay, answer what you guys did wrong with your model and how you would fix it. Okay, once I've checked you off, again, you guys can come talk to me. Your code word for this one is going to be C star. Okay, so come tell me that. Come tell me, show me how you guys maybe would check your models, and then you guys will be allowed to go in and make corrections on that. Okay, if you have any questions, let me know. If not, I will talk to you soon.